There's one more section on this foldable we haven't talked about yet, and those are what are called false shortcuts. So it is backwards on my screen here, so the false shortcuts, if you have the foldable, is in the lower right-hand side. But let's go, the second page though is not backwards. So over here, and I'm gonna draw kind of a line here so that we can focus on this section. The section here in the lower right-hand corner is where typically we think of as false shortcuts because they can be common abbreviations, but they do not guarantee congruence. So the two false shortcuts, the first one is AAA, angle, 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 and SSA. Okay, so angle, 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 of course, refers to having 3 angles in one triangle congruent to 3 in another. Now, the reason that doesn't work, and I'm going to do my best to draw this, but it's not going to be perfect, but try to envision you have a triangle, and I draw a second triangle where the sides are longer, but the angles are the same. Okay, so for example, these 2 angles here could be congruent. The top 2 angles could stay congruent, and then the third angle could be congruent. But I could stretch the sides out in one of the triangles, therefore it doesn't guarantee congruence if just the angles are fixed. Okay, so in Schoology, I do have a link to a, oh gosh, what's the word? It's like a demonstration, or it's a program where you can drag around the triangles and actually see how that works, okay? The second one, and maybe you've been wondering, notice I did write it SSA, side, side angle, or have you been wondering where is the ASS theorem? I know that's something that often comes to mind, like, okay, here are all these A's and these S's. But it's not because of what it spells, okay? But wouldn't that be hilarious if we could, you know, quote that as a reason that triangles are congruent? This one's going to be a lot harder for me to sketch accurately, so I'll just give you an overview, but I do have another link in Schoology that demonstrates it very well. So if you had a triangle, I'm just going to start out with a triangle, draw piece by piece. Let's say I fix this side in triangle 1, and I fix that side in triangle 2. Okay, so let's say I do the same over here with the, let's see, let's try to fix this side, and I'll try to draw what appears to be about the same length. All right, so if let's say I start to draw the bottom of this triangle and I fix the angle, and the bottom of this triangle and I fix the angle, okay? So I could elongate this side where I take, for example, maybe I take this side and I'm able to move it further out. So let me get a different color here. I'm able to move it so that this side no longer is the same length as this one. Okay, so when we have the combination of 2 sides and an angle, where the angle is not in between the 2 sides, it does not guarantee congruence, okay? So again, I really want you to go to those 2 links I have in Schoology and play around with that demonstration. It allows you to drag the vertices of the triangle and make either the angles or the sides change to show you why we can't just have angle, 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 or side, side angle, okay? So bottom line here, let me go back to page 1, the front, I guess. There are only 5 ways to guarantee congruence, okay? And so those are the 5, I call them shortcuts because we don't have to go through all 3 sets of sides and all 3 angles. We can just go through pieces of the triangle, but these are the only 5 combinations that will guarantee that all the other parts stay the same as well. So these are what we typically call false shortcuts.